Hello students, today we are going to discuss composite functions, exercise number 1.2, and this exercise number 1.2 divided into two parts. Part 1 we are going to discuss 1 to 4 problems, part 2 5 to 7 problems we are going to discuss. Okay, as usual before going to our class we just pray, then we'll start. Let us close our eyes. God, kindly provide your knowledge and wisdom to solve our math problems and our daily life problems. Thank you, God. So now let's move on to the part number 1 to 4 problems. Yes. Let's see now if capital A is equal to 1, 2, 3, 4 and capital B is equal to ABCD, then define 4 bijection from A to B and also find their inverse functions. What is bijection? You already know that if function is 1 to 1 and onto, then that is called as bijection. So if function is 1 to 1 onto, then only the function defined, then only their inverse functions are defined. Now we need to find any 4 inverse functions. So how to write those all the 4 with the diagrams? Let me explain to you. So now first I'll draw here capital A. This is our solution 1, 2, 3, 4, and capital B A, B, C, D. So first A is connected with 1 is connected with A, 2 is connected with B, 3 is connected with C, 4 is connected with D. So this function is F. Okay. So now what is here F? So F is equal to 1 comma A, 2 comma B, 3 comma C, 4 comma D. Here clearly you are observing that. So here code this domain and then range. So here range is equal to the codomain. Because of that reason it becomes as a onto function, and 1 to 1 means you are observing that each is having the unique relation. So now F is that, and what is your F inverse means just reverse of this. So 1A is nothing but A1, next 2B is nothing but B comma 2, next C 3 comma C is there, so C comma 3, next D comma 4. So this is about your F and F inverse and first function completed. So how many functions we want here? Here we want, they said that 4 we want. So just what I do here it is, I will draw as a diagrammatic form. 4 I need to complete. So let you all observe. A, B, A, B, A, B. Now see. 1, 2, 3, 4. A, B, C, D. Here also same. So 1 to B, 2 to C, 3 to D, 4 to A. Same method now. 1, 2, 3, 4. A, B, C, D. So 1 to C. So next one what I can write? 2 to D, 3 to A, 4 to B. Same method, one more also. 1, 2, 3, 4. A, B, C, D. Now check carefully here. So first 1 to D I'll keep. Next 2 to A. And then 3 to B. 4 to C. So now functions all you got. At the same manner, F inverse also you can. So now what about this figure 2 and this figure 3? And this is your figure 4. So from figure 2, what is your F? So F is nothing but 1 comma A. Check 1 comma A? No, 1 comma B. So next one 2 comma C, 3 comma D, 4 comma A. What about F inverse for this? So F inverse is equal to, just reverse it. So B comma 1, C comma 2, and D comma 3, A comma 4. So B comma 3, A comma 4. So this is about your F inverse. And again we'll go for next figure 3. What is your F1C? So now 1 comma C, 2 comma D, 3 comma A, 4 comma B. And what about your F inverse here? Same method. C comma 1, D comma 2, A comma 3, B comma 4. So C comma 1, then D comma 2, then A comma 3, next B comma 4. B comma 4. So that is about your figure number 3. Now we'll go for figure number 4. That is F is equal to, what is your F here? 1D. So now write 1 comma D, 2 comma A, right, 3 comma B, 4 comma C. And what about your F inverse? D comma 1, A comma 2, D comma 1, A comma 2, B comma 3, C comma 4. So B comma 3, C comma 4. So this is about your first question. I hope so you all understood. Let's move on to the next question. Alright, let's move on to the second. If f maps are to R such that f of x is equal to x cubed minus 3, then prove that f inverse exists and find its formula. Thus find f inverse 24 and f inverse of 5. You know that if f inverse exists, you want to prove means first you need to prove that the function is 1 to 1 and onto. So how to prove first function is 1 to 1? So let whichever given that we'll write. So f maps R2 are given this. F of x is equal to x cubed minus 3. So after writing this, what we can write now? So now let, so for 1 to 1 I need to find now. So first write 1 to 1. For 1 to 1 what we need to do? Let x1 comma x2 is belongs to R. Then what is our assumption next one? So we can write here f of x1 is equal to f of x2. So at last we need to prove x1 is equal to x2. Then it is going to be 1 to 1 function. So what I need to do here, wherever in this x is there in the f of x, we need to put x1. Then wherever x is there, we need to put x2 in this f of x2. So let we do what we get, x1 cube minus 3 and here x2 cube minus 3. Now let observe, minus 3 get cancelled. Then x1 cube is equal to x2 cube get cancelled. At last what you get, x1 is equal to x2. Therefore x1 is equal to x2. If x1 is equal to x2 is not happen, then what we can write? Hence so f of x is 1 to 1 function. So first 1 to 1 finished. Let's move on to the onto. So onto function, if I need to prove what I need to prove. So here I need to prove that a range of f is equal to codomain of f. So how can I do these all? Just let's see these all things. Okay. So now let's move on to that onto. So now we are going to that onto. So onto place what we do here it is. So let y is belongs to R. So first let y is belongs to R because we need to prove at last f of x is equal to 1. So to prove that, what we do is just now let y is equal to f of x. So y is equal to, what is f of x? You know, x cube minus 3. Write that x cube minus 3. Now find from this x value. So your minus 3 comes to your plus 3, so y plus 3 is equal to x cube. Your cube is there, it sends to another side, it becomes as 1 upon 3. So now y plus 3 whole power 1 upon 3 is equal to x. So now what I need to do is wherever x is there in the f of x, substitute this, and if you get f of x is equal to y, then it is one-to-one function. So for that purpose, what I will do, just you can observe carefully now. So we know that f of x is equal to x cube minus 3. So now f of x is equal to, what is x cube you know here? X is nothing but here 1 y plus 3 whole power 1 upon 3. X cube is nothing but y plus 3. Just substitute y plus 3. Y plus 3 minus 3. Minus 3 plus 3 get cancelled. F of x is equal to y you got. So here y is belongs to R. Because of that reason we can say it is also a onto function, because this is what codomain is equal to the range. So because of that reason, so now I'll write, if you want I'll write this also, range of f is equal to range of range of f is equal to codomain of f. Hence function is f is onto. So if a function is one-to-one and onto, then how to find this f inverse formula? So I will complete here itself, that is f inverse formula. It is very simple. So now here it is, you already found here x value, right? So x is equal to y plus 3 whole power 1 upon 3. X means, what do you know here? Here f is multiplying comes to here division. So we can write f inverse of y. This implies f inverse of y is equal to x. So now f inverse of y is equal to, what is your x here? y plus 3 whole power 1 upon 3. So now I just want to replace y with the x, then you get the formula. So f inverse of x is equal to x plus 3 whole power 1 upon 3. So formula also we found. So what we need to find in this place, we already if f maps are to us such that f of x is equal to x cube minus x cube, prove that f inverse exists. So here you found that f is becomes as a one-to-one and onto, therefore f inverse existed. F inverse is existed, then formula for this f inverse is this. So after finding that, you need to find f inverse of 24 and f inverse of 5. Let me find out that. Let me find out f inverse of 24 and f inverse of 5. Okay. So now first f inverse of 24. So wherever x is there, just substitute 24. 24 plus 3 whole power 1 upon 3. This becomes 27 whole power 1 upon 3. 3 cube is nothing but 27. So now 3 power 3 whole power 1 upon 3, 3 get cancelled, and 3. So f inverse of 24 is equal to 3. Now let me move on to the next. Next, f inverse of 5. So can you tell f inverse of 5 how we get? So wherever x is there, substitute 5. So 5 plus 3 whole power 1 upon 3, 8 whole power 1 upon 3. This 2 power 3 whole power 1 upon 3. 3 get cancelled, you get answer as 2. So first, what are your answers? F inverse of x is equal to x plus 3 whole power 1 upon 3, and f inverse of 24 is equal to 3, f inverse of 5 is equal to 2. So in this way we have to solve your second problem. Let's move on to the next problem. So here in this second problem, what we found, if we want to find f inverse exists, first we need to prove one-to-one and 2, then f inverse existed, then find the formula. After finding formula, f inverse of 24, f inverse of 5. Both we have to find out. I hope so you all understood. Let's move on to the next problem. Alright, let's move on to the next question. If f maps R to are defined as f of x is equal to 2x minus 3, f of x is equal to x cube plus 5, then prove that f is bijection in both conditions and also find f inverse. So let me try solve these all problems. Same like second problem method. So let first whatever they given that we need to write. So given is here f maps R to R, and what is your first one? It is f of x is equal to 2x minus 3. So if f inverse, f is bijection, if I need to prove it is 1 to 1 and 2 I need to find, then I need to find formula for f inverse. It is very simple. So first what we need to do, go for 1 to 1. So same, let x1 comma x2 is belongs to R, then f of x1 is equal to f of x2. Wherever x is there, x1, x2 is substitute. So 2x1 minus 3, 2x2 minus 3, minus 3 cancel. 2x1 is equal to 2x2, 2 cancel. x1 is equal to x2. Therefore, f is 1 to 1. First one 1 to 1 finished. Then on to we need to go. So on to what we need to do? Let y belongs to R, we need to think. Then that y is equal to f of x. Y is equal to, what is your f of x here? 2x minus 3. Then find x value, minus 3 comes to your plus 3. So y plus 3 is equal to 2x. And 2 is multiplying, go to that side division. So y plus 3 upon 2 is equal to x. So now x you got, and you found this form, you are going to get real number only, because any fraction form whatever you get, that is real number. And I already said to you to find that as a proof manner. Wherever x is there, that is substitute this y plus 3 upon 2, then you get f of x is equal to y. Therefore it is going to be onto function. But directly what I will do here is, for every y belongs to R. So for every y belongs to R, therefore it is onto function. So here y belongs to R means here x also belongs to R and y also belongs to R. So because of that reason, that is, we can say that it is a range of function is equal to the codomain of function. Therefore it is onto function. And find the f inverse. So you already know here it is x is equal to that, but here this implies what we can write, f inverse of y is equal to x. So let me write f inverse of y is equal to x. Then f inverse of y is equal to, what do you know x? X is nothing but y plus 3 upon 2. Right, that y plus 3 upon 2. Now formula 1 means just replace in the y plus x. So then f inverse of x is equal to x plus 3 upon 2. So this is about your formula, and here if you write for every x belongs to R. So this is about your first question. In this third question, first part is this. So same method we have to find your second also. Let's move on to that. Right, let's move on to the second part. It is f of x is equal to x cube plus 5. And here also same for 1 to 1. Let x1 comma x2 belongs to R. We can think f of x1 is equal to f of x2. Wherever x is there, substitute x1. Wherever x is, substitute x2. Then what do you get? x1 cube plus 5 is equal to x2 cube plus 5. So now you have 5 get cancelled. x1 cube is equal to x2 cube get cancelled. x1 is equal to x2. Therefore f is 1 to 1. Once it is finished, then move on to the onto function. So first, if anything want to be onto, so let y belongs to R, we can think first. Then y is equal to f of x. Anyway, this implies also right here f inverse of y is equal to x, because here f, if you go to that side, it becomes as f inverse. Okay, so now after completion of this, if you want in detail how it was came and result, you just check our examples problems I was explaining, that I was explained clearly for you. Okay, let's move on to this. So y is equal to, what is your f of x? X cube plus 5. So right here x cube plus 5. Plus 5 comes to your minus 5. That is equal to x cube. And then x is equal to y minus 5 whole to the power of 1 upon 3. So now here also cube root came. Cube root means it is again irrational number. So irrational number or the rational number, whatever you get, it is belongs to the R. So here for every y belongs to R. Therefore directly it is the codomain is equal to, codomain of f is equal to the range of f. So therefore anyway I'll write here, therefore codomain of f is equal to range of f. So therefore f is onto. Once f is onto, then what we can write? We need to find f inverse. So you already know that f inverse of y is equal to x. So f inverse of y is equal to, what is your x here? X is nothing but y minus 5 whole to the power of 1 upon 3. So y minus 5 whole to the power of 1 upon 3. So now just in the place of y we need to substitute x. So now f inverse of x is equal to x minus 5 whole to the power of 1 upon 3 for every x belongs to R. This is nothing but your f inverse. So for f of x is equal to x cube plus 5. So this is about your third problem. And the fourth problem, so it is, I'll write the question and you just kindly go through your example number 4 previous video. Then you have to solve it. That is your homework. I'll write the question. Okay. So let's move on to the next question. Alright, this is your fourth question. If A is equal to 1, 2, 3, 4, B is equal to 3, 5, 7, 9, C is equal to 7, 23, 47, 79, and F maps A to B, G maps B to C such that F of x is equal to x plus 1 and G of x is equal to x square minus 2. Then find G circle F whole inverse and F inverse circle G inverse in ordered form. So it is very simple question which in the last video, fourth question in the examples, we learned such kind of question, and in your class also you already learned this. Just refer your notebook and understand it and refer last video. Understand. If you have doubt, you just comment on YouTube page, and so that I can help you all. Okay, so this is about your part number 1, 1 to 4 problems of exercise number 1.2. So here it is, refer last video. Okay, so last video you refer or your notebook. Okay, so refer those. You can find out this. That is also example number 4. Okay, so this is about this is homework problem for you. So you can do homework and tell to me if you find any difficulty in that, so that I can help you out. So that's all about this part number 1, 1 to 4 problems. So let's discuss in the part number 2 your 5 to 7 problems. So that's all about today's class. God bless you all.